Your competitors and the world around your organization are spinning faster and faster, and you're struggling to achieve the necessary speed to keep up with it? You've tried to set up your organization and your IT in an agile way, but the changes show only limited effect? If this sounds familiar to you, then this demo might be something for you. My name is Markus Schattauer. I'm an IT consultant at Fujitsu for the topics DevOps and Cloud Native. In this demo, I would like to show you how we use CICD as part of a DevOps implementation to automate the path of an application from source code to productive operation to be truly fast and agile. Many organizations struggle with the introduction of agility and fail to generate value from it. This is often due to the fact that the agile transformation has not been fully implemented, because agility is much more than just dailies, Kanban boards, or even a buzzword. Agility is mindset, is culture, and must be enabled by methods and tools. A core aspect of agile software development is the frequent creation of product increments, which may go into production or at least be tested in staging environments. Often, IT operations are historically unprepared for such short release cycles, instead being used to slower speeds, and as a result can no longer keep up. DevOps is a framework that brings agility, as achieved by Scrum or Kanban in development, to IT operations as well. Then it is possible for IT to take full advantage of agility and not to minimize it through problems in operations such as long release cycles. For this, DevOps defines 4 core aspects that need to be considered. Culture. An agile culture, for example, is achieved by implementing Scrum with values like openness, focus, commitment, courage, and respect is fundamental. Automation. Automation accelerates our processes, creates capacity, and increases reliability. Measurement. The measurement of important KPIs is the basis of a continuous improvement process. Sharing, so that important knowledge is visible to relevant stakeholders of processes. But enough theory for now. Let's jump right into practice and take a look how we can implement these aspects. The core of our implementation is GitHub and GitHub Actions. But what is GitHub and GitHub Actions, and why do we use it? GitHub is a source code management system and a well-known platform for developers. GitHub Actions is an automation or a CI/CD tool by GitHub. With GitHub and GitHub Actions, there's a single place for code and operation and automation, which is great for sharing and an open culture. From a technical perspective, the case for GitHub Actions as a CI/CD tool is strong. It's hosted, so we don't need to do that. It has a marketplace with ready-to-use pipeline jobs for a simple start, and it has modern, contemporary architecture fitting our cloud-native approach. What we want to achieve now with GitHub Actions is the automation of processes around the integration and deployment of software. In example, the development of a continuous integration, continuous deployment pipeline. Steps of such a pipeline could be the build of the software to an executable artifact, including necessary dependencies. In our example, a simple Python web application that simulates a government agency into a container image that can later be run in our Kubernetes environment, for example with tools like Podman or Builder. The testing of the software, for example via unit, integration or load tests, or even automatic code analysis to ensure automated that the software works. Important for high code quality is a high code coverage and a useful combination of different test types, because we want to be sure that our software product works and is ready for usage if it passed the tests. To reach these goals, it might make sense to develop your software test-driven. For our web application, we run unit and integration tests, which are testing the pages of the application to ensure they are working well. Security scans of the artifact. Before our software can be productive, we also need to ensure that we do not get any vulnerabilities or exposures in our environment. Therefore, we use a security scanner like Trivy to scan our artifact for known CVEs. After that, our web application is now ready for deployment, and in our case should be moved directly to production. To automatically manage environments, including production, a high maturity level is required. Standardization, existing automations, and central control mechanisms are essential. As the means of choice for these requirements, we rely on containerized workloads running in Kubernetes clusters as the operating environment. For the administration of Kubernetes clusters in different cloud environments, we rely on Rancher, which is perfectly suited for orchestrating containerized applications with Kubernetes. This allows us to abstract our infrastructure and hardware very far and focus on the points that are relevant for us. All relevant aspects are implemented as code and can therefore be persisted, versioned, and tested. In addition, Kubernetes creates foolproof scaling for us with a high level of reliability. We simplify the management of our Kubernetes clusters with Rancher as a Kubernetes management tool for all our clusters, whether in our own data center or in the public cloud. For the deployment of our application, we want to use a GitOps approach, as the resources we need for deployment are already written in code as so-called Kubernetes manifests. These are stored in a Git repository, which represents a single source of truth for our deployments and our production. The GitOps tool of our choice is Fleet, which is already included in Rancher, so no hosting of a separate system is necessary. Also, Fleet is very suitable for multi-cluster deployments. As an input parameter, Fleet gets the GitHub repository containing the information required for deployment in the form of manifests. It then automatically deploys the new version of our web application to the Kubernetes clusters we specified. If something does go wrong, it doesn't matter because the old version remains in the cluster until our new one is successfully started. In a time of around 3 minutes, which is about the time I presented our CI/CD pipeline, a new version of our software with updated design was made available by GitHub Actions and Fleet and is now live. We've now seen how our system works and what it can do, but the pipeline I've shown here is only an example of an implementation that fits our application. For other software products in different organizations, other pipeline steps make sense. But that's the advantage of such a pipeline. There are practically no limits and a wide variety of things can be automated. We could include a chatbot that informs the team about pipeline successes and failures. We could implement an integration to the public cloud providers that deploys our artifact there, or even order a pizza as a reward for your developers after a successful deployment. Did you know that Domino's Pizza has an API you could use for ordering? Well, I didn't. So, let's wrap this up and take a look at the key advantages of our CI/CD pipeline. The use of a source code management system for both the source code of an application and the configuration and automation scripts creates a high level of transparency and reproducibility. At the same time, development speed and quality are permanently increased since changes and enhancements can be made immediately and provided automatically. Time-consuming and error-prone manual processes are thus avoided. And, last but not least, short release cycles allow true agility and fast reaction times in a highly dynamic market that must constantly adapt to new situations and customer requirements. I hope you enjoyed our little demo. If you have any questions or want more information, feel free to contact me via email. Have a nice day here at SUSECon. Goodbye.